Hi, and welcome to my presentation. In this video, I am going to talk about the role of continuous integration in Agile development. Agile is an approach to software development that encourages collaboration across an organization. Waterfall model refers to a linear sequential life cycle model, whereas Agile refers to a development process as an subsequence of development and testing. Waterfall is a regimented software development approach, while Agile is a dynamic software development approach. This presentation explores a key workflow process in Agile development known as continuous integration. This is a development practice that everybody thinks they are doing, but it is widely misunderstood. Early days of software development might have seen integration executed after weeks or months of coding. You will have more than a few errors and faults that will take a lot of effort to repair with that much time in between coding and combining everything. This is the reason CI was developed. In modern software engineering, continuous integration is the technique that is designed to continuously merge. Continuous integration is the practice of integrating source code changes frequently and ensuring that the integrated code base is in a workable state. Grady Booch first proposed continuous integration. Kent Beck then picked it up and extended it using extreme programming. Adding changes to a shared source of code on a regular basis, usually multiple times a day, is what continuous integration means in software development. CI's goal is to find and fix integration problem as soon as possible. This will speed up development, make it easier for people to work together, and result in better software quality. CI is all about automating the process of putting changes to code together, and continuous delivery is all about automating the process of getting that code to the right setting, which is outside of the scope of this presentation. The major objective is to make sure that the software can be made public at any given moment. It does this by making sure the software is always ready to be deployed. This reduces the time between making software and putting it into use. The software development business uses CI as a standard tool to keep an eye on how major projects are managed. CI has lots of automation tools built in, like version control, syntax review, code quality testing, and more. To implement continuous integration, you will need a version control system. It stores all the source code checked in by the team and acts as the only source of truth. Automated build and unit test is not sufficient if the code written by a developer works only on its machine. Every commit that makes it to the version control system should be built and tested by the independent continuous integration server. Developers should get feedback on their commits. It is important that everyone on the team follows the practice of checking incremental changes rather than waiting till they are fully developed. Their priority should be to fix any build issue that may arise with the checked-in code. The following diagram shows continuous integration as part of a full continuous integration and continuous delivery CI/CD process. CI is just the first step of a modern software development pipeline. The next steps involve automating integration and acceptance tests and deployment to production in the continuous delivery and continuous deployment steps that are both outside of the scope of this presentation. Let's try a little challenge here. Can you guess which kind of activities the CI might have? Please pause the video and try to figure it out. I will give you 10 seconds to do that. Okay, I hope you were able to guess it. This figure shows 4 elements that is essential for continuous integration to happen. Develop describes the practices necessary to implement stories and commit the code and components to version control. Build describes the technique needed to create deployable binaries and merge development branches into the trunk. Test end-to-end describes the practices necessary to validate the solution. Stage describes the steps required to host and validate solution in a staging environment before production. Let's look at the advantages of CI. CI enables a quick feedback mechanism on the build results. It helps collaboration between various developer teams within the same organization. It decreases the risk of regression since the code is often checked by other developers. It allows earlier detection and prevention of defects. CI reduces manual testing efforts. It can provide a facility of falling back to previous version in case of any problem within the current build. In summary, continuous integration helps testers to perform automation effectively to find defects at a faster rate and improve the regression results. The system will also show portion of the area is covered by the test. The automation report also lists how many user stories and pieces of functionality exist. Automation also makes life easier for testers by reducing the amount of work they have to do manually. Testers can also manually test the area of failure and collaborate with the developers to fix the defects. There are several tools that are being used in organizations as part of continuous integration to build the automation scripts. Few examples of the tools are JUnit, selenium, and sonar. Thanks for watching my presentation. I will see you in the next video.